Hello everyone, this is Grizel and I'm back with another video for this week. This week's video is going to be about question 11, application number 1. Solve the following application problem. Be sure to show your system of equations and the steps to solve the problem. Application problem. It takes a boat 2 hours to go 16 miles downstream with the current and 4 hours to return against the current. Find the speed of the boat in still water and the speed of the current. Alright, so let's start with step 1. Identify the x and y. Now, you can see right here, I color-coded a lot of the text. The reason for this is because it'll be more easier to identify each value throughout the video. I color-coded x as orange, and x is going to be the speed of the boat in still water, as you can see here. And then y is color-coded with purple, and y is going to be the speed of the current. Now, we're going to move on to step 2, and you're going to see why this is green and this is red. Now, step 2 is identify and create x and y equations using the formula rate multiplied by time equals distance. Alright, so let's zoom that out a little bit. Alright, that works. So I created a table right here so you could see the values better. So we got 2 rows here. We got with the current and against the current. Alright, so what we're going to do here is we're going to identify the rate, time, and distance for both. Alright, so with the current, it's going to be x plus y for the rate because you're going in a positive flow, which is the with the current. With is viewed as a positive, so that is why we have the add sign. And then it took 2 hours, according to the text right here, 2 hours to go 16 miles downstream with the current. So we see here 16 miles for the distance, and it's going to be also 16 miles for against the current. Alright, so let's go and explain the against the current. The word against is a negative. It gives a negative for the rate. So rate is going to be x minus y. And then the time is going to be 4 hours. As you can see right over here, it says 4 hours to return against the current. And we still have the 16. Alright, so now let's move down to here and start with the current equation. So our with the current equation is going to be 2 times x plus y equals 16. Our goal is to get the x and y by themselves. So we're going to divide 2 on both sides to get x plus y equals 8. Now for against the current equation, it's going to be 4 multiplied or times x minus y equals 16. And we divide 4 on both sides to get x minus y equals 4. Now, both of these equations are ready for step 3. Step 3 is add the equations to get x. Alright, so we got the with the current equation, which is the x plus y equals 8. And then we have the against the current right here. We have that right over here. So now we add both of them and we will get 2x equals 12. The y's cancel out, which is why you can't see the y there. And we divide 2 on both sides to get x equals 6. Alright. Now we move on to step 4. Plug in x into the first equation to get y. To be honest, you could plug x into the second equation. It's just one extra step. but I chose the first one because it's one step quicker. So let's go down here, and you're going to see the x plus y equals 8. Drag down over here, x plus y equals 8. Plug in 6 for x, which is right over here, the 6 plus y equals 8. Now we subtract 6 on both sides to get y equals 2. Now we got the solutions for x and y. And we move on to step 5 to identify solutions. Alright, so now we know the speed of the boat in still water is 6 miles per hour, which is our x right over here, and the speed of the current is 2 miles per hour, which is that y over here. And those are the solutions to this week's problem. I hope this helped anyone who is watching, and I hope everyone has a wonderful day. Thank you all for watching.